Right now we're going to look at an interactive notebook page for factoring. This is going to give you 4 different ways to factor, and I know your notes are going to do that, but these will give you some different problems to look at as well, and will allow me to give you a PDF form for you to look at all at once as well. Without having it all in one place might be helpful. So we're going to start with a GCF problem, or two problems. Let's see if I can get this to look better. There we go. So GCF. So we're going to start with number 1, and I'm going to look at all 3 terms and see what number I can divide all 3 of these by. So I'm going to start with a 6. I know that 6 can go into 24, it can go into 18, and it can go into itself. So for sure 6 is part of the GCF. Then I see that this term has an A and a B, this has an A and a B, and this also has an A and a B. So 6AB is also going to be part of the GCF. So if I divide every term by 6AB to factor it out, that's going to leave this first term with 4A. And that's it, because the B was taken away, one of the A's, and then 24 divided by 6 is 4. Bring down your minus. 18 divided by 6 is 3. A divided by A, the A is gone. B squared divided by B is just B. Bring down your plus. 6AB divided by 6AB is not 0, it is 1. If you were to take 6 and divide by 6 in your calculator, you would get a 1. And then I look within the parentheses to make sure there's nothing else I can do. There is not, so 6AB parentheses 4A minus 3B plus 1 is my final answer. Another GCF problem is this one here for number 2. I'm looking first at the coefficients. What's the largest number that I can divide into both of those? It would be a 4, so I know we're going to use a 4. Then I see there are 3 x's and 3 y's, 1 x and 2 y's. So I can take out 2 y's and 1 x. So that's going to be my GCF. When I factor out 4xy squared from 8x to the third y to the third, that's like saying 8 divided by 4 is 2. X to the third divided by x is x squared. Y to the third divided by y squared is just y. Minus 4xy squared, that's itself. I got to put a number there. 4 divided by 4 is 1. So that's going to be my final answer. Now we're going to look at MAM factoring. This is where we draw the boxes. Alright, so I'm going to label this M, A, M. I'm going to come over here and draw a box. Here, let me shut this one so this one's not distracting. And then my multiply number is going to be 2 times negative 4. That's negative 8. My adding number is going to be positive 7. So I need 2 numbers that multiply to make negative 8 and add to make positive 7. If it multiplies to make a negative, I need a negative and a positive. If this number is positive, that means the larger of the 2 is going to be positive. So when I think about multiplying to make 8, I think about 2 and 4 and 8 and 1. The only way I can make a 7 out of those combinations is an 8 and 1. And I said the larger number needed to be positive. So we can check. 8 times negative 1 is negative 8. 8 plus negative 1 is positive 7. So now we don't need these 2 numbers anymore. I see over here that I have a leading coefficient of 2. So remember from Algebra 1, we're going to keep the number, split the variable, keep the number, split the variable to create fractions. And then this number and this number drop into the denominator, and we're checking to see if we can simplify these fractions. 2x minus 1 is not going to simplify, so I'm going to use that one. This one simplifies, so that's going to simplify to 1x over positive 4. So now I can take this one and write it in parentheses as well. So that means my 2 binomials that I get are 2x minus 1 and x plus 4. Alright, this next one has a variable on the back, so we'll need to make sure we pay attention to that when we get to that point. I'm going to label the trinomial ma'am and draw my box. My multiply number is 1 times positive 32, and my adding number is negative 12. So if something multiplies to be positive but adds to be negative, that means both of these are negative. So what are two numbers that multiply to make positive 32 and add to make negative 12? Let's see. Looking for my calculator. So my brain's not working. 8 and 4. Negative 8, negative 4. Okay, so that works. So we don't need these two numbers anymore. I don't have a leading coefficient of anything other than 1, so when I make these fractions, they're not going to simplify. But I am still going to make them. Keep the coefficient, split the variable, and drop the negative 8 and the negative 4 into the bottom. Now I'm going to need to make sure that I drop a y in the denominator as well. So when I write my parentheses, I'm left with x minus 8y and x minus 4y for my final answer. The next type we're going to look at is difference of squares. These are the easiest in my opinion. First, you need to check for 3 things, and I'm going to write it over here. They both are perfect squares. It needs to be binomial, so 2 terms, and there needs to be subtraction in between them. So that's the criteria for our difference of squares. So I'm going to set up 2 parentheses here because these are both perfect squares. They're a binomial, or this is a binomial, and it has subtraction in the middle. So I say, how do you make 25x squared? I make that by saying 5x times 5x. So I put those in the front. How do you make 9? 3 and 3. So I put that in the back. And then I need different signs. I need plus and a minus. You could write minus and plus. They just need to be different signs in the middle. And that's your final answer. You're going to do the same thing over here. This is a perfect square. This is a perfect square. This is a binomial. There is subtraction in the middle. So I'm going to set up 2 parentheses. How do you make y to the 6th? Y to the 3rd times y to the 3rd. How do you make 49x to the 4th? 7x squared and 7x squared. And those go in the back. Then I need different signs. I'm going to do minus, plus. Check and make sure you can't do anything else. Sometimes you can do another difference of square. Sometimes you can't. So that's my final answer. Last set is going to be factor by grouping. This is where you do GCF 3 times. So I'm going to split this up into groups. Group those 2 together and those 2 together. And now I'm looking for the GCF here. I'm going to write GCF 3 times on here. Alright, so what's the GCF in this group? That would be x squared. When I factor that out, that leaves me with x plus 3. Then I need to find the GCF in this group. 6. Now it leaves me with x plus 3. So see, we have x plus 3 and x plus 3. That's how it needs to be. That means that that is my main GCF. So I put it in the front in parentheses. And then x squared plus 6 also gets put in its own set of parentheses. And that's my final answer. Alright, last one. Same type, factor by grouping. I'm going to group the first 2 together and the last 2 together. What's the GCF in this group? It's x squared. When I factor out x squared, I'm left with x minus 1. When I look in this group, my GCF is going to be a -5. And I'm doing that because this negative in the front. I never want to leave a negative in the front of a set of parentheses. So I'm going to factor out the -5. And that's going to leave me with x minus 1, which sets up perfectly because x minus 1 is written twice. That's my GCF I'm going to put in front. And then I'm going to put this x squared and this -5 in the back. And that's my final answer. And that's it for this interactive notebook page on factoring.